enkuba eyagala kujja. Yeah, this is what we call the water-powered spiral water wheel pump. And as you can see, it is rotating very well using the velocity of flow of water. And our aim is to deliver water up to a point 50 meters upstream, and we are looking at a head of 20 meters. So it's happening. Eh. Oh, would you? The what? The scoops? They need bigger ones. Until now I use the design considerations. The pipe is swallowing water very fast, eh?
Hello? 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 Hey.
Yeah, as you can see, this whole site has a very rocky basement. So we have really tried all the profile of this river within the test study area Mr. Nwamanya Golden used, and we have really failed to achieve a slightly deep end with good velocity. Well, this part is a little deep, as you can see where my foot is. It's about 2 feet deep, which would be a very favorable site as far as depth is concerned. But then the velocity here, you can see water is really very stagnant around this place, so that forced us to move and look for a better site. We tried actually even excavating to remove some of the rocks underneath, just to see that we provide an optimum depth for rotation of our pump. And as you can see at this point here, using those sandbags, we blocked out on that side, so we have most of the water flowing this side. And as you can see, the velocity here is increased. Yeah, and that is very interesting that we are able now to have the pump rotating. Same thing downstream. Actually, I'm going to take you to the exact site where Nwamanya Golden tested this pump from. Help me with this camera. Yeah, still as you can see, the whole basement is rocky. Yeah, as you can see here, it's like I'm walking on top of water because it's not deep enough. Here the water level is stagnant, but as we continue moving, this is the exact site where Mr. Nwamanya Golden in 2017 tested this prototype. But as you can see, yeah, this is already rock that I've encountered. As you can see, this is how deep it is. So since his was being supported by a stand, and by the time he tested, the water level was about here where you see this rock, and those are about 2 feet at the time of my testing. So it's very hard to get an optimum depth here. So the best we can do is maybe with time ensure that we excavate at wherever we want, but provided we have accommodated the velocity we need, we excavate and make sure that at least a third of the pump is immersed, so that we have a higher speed of rotation of the pump. And also, as the design consideration dictates, we are supposed to have 30% of the total diameter of the pump immersed, which you can see at the other side we have even not achieved that. But what is the good news is that the pump is rotating and we are able to get a discharge at the end of the pump. So basically it's just the test site that has limited us, but I believe in a better site where we can easily get a depth even of about 40 centimeters, because that will cater for the 30% of our 30% of the total diameter, 30% of the diameter, as you can see. So that is basically it with the spiral powered wheel pump. And yeah, I think for today we are going to call it a day. And I'm very sure I'm going to make some recommendations for that very pump. And we hope to get a better pump than this, because right now I'm very sure I have a pump that is more efficient than what Mr. Nwamanya constructed. So I hope with the recommendations I make, we shall have someone redesign that pump and get something better. As I also benchmarked from Mr. Nwamanya's prototype to achieve this. So no one has monopoly over knowledge, and I think there's still need for improvements, as I will recommend in my report. Otherwise, for today, thank you very much. Thank you, my team. You can give me that camera. And we organize to see that we